Okay, so let's keep expanding on this notion of a subset. So again, let's just try to connect everything together to see the global picture. So on the last example, I used, I think it was in pink, I had the subset, I had Maria and Danny, right? Or I think Caleb and, oh, I forgot who it was, Caleb and Jeff were a subset. And so here, okay, this is a proper subset of G4. This should be exactly the same. If it's not G4, please change it, but I'm pretty sure it's yeah, it is G4. Okay. I can also say this is a subset of the big set S, right? I mean, whoops, Maria and Danny, right? They live in G4, but they also live in S. Okay, so I'm looking at number 55 through 60 in your book on page 68, and it says list all the subsets of the given set. So you'll have these problems in class, but I want to do it with this one, and I'll do one of these as well. Okay, so if the directions are list all the subsets, right, of the given set, and I don't know, let's just call B. Let's just say call it B. Okay, so B is equal to this subset. Okay, so what are all the subset of B? Okay, well, we know that the subsets could be the whole set, right? So one of the subsets, it's definitely B itself. So maybe let's write that just in pink. Okay, so Maria and Danny, right? That's a subset of itself. Another set could be, well, it could just be Maria, right? Maria is still, this set still lives in G4, right? It's just a set with one student, but it still lives in G4. It belongs to G4 and S. We can also say the set just Danny, right? This is usually called a singleton set because there's a single element in the set as opposed to multiple elements. So far I have one set, two set, three sets, and there's actually one more set. And that's actually the empty set. And that's by definition, the empty set, and again, this is the empty set because it's a set, right? That's the set notation. The collection of what? Of nothing. So I can also write this as, again, the 0 with the slash. These two symbols mean the empty set, right? Or even if you want to write equals, and any one of these represent the empty set. This one, and this one. So here, how many subsets? So we have 1, 2, 3, 4. So there are, so the question, so there's 4 subsets, right? And notice the cardinality is different, right? If I call this, okay, well, this is actually, technically it's B. I don't know, B1, B2, and then, well, we know the empty set. We know N, the cardinality of B is 2. The cardinality of B1 is 1. The cardinality of B2 is also 1. And then the cardinality of the empty set is what? Well, how many elements does the empty set have? Well, it has none, so the cardinality of the empty set is just, so we know it's 0, okay? This is a 0, okay, and this is not a 0, right? That's a set, specifically a set that's empty, right? There are no elements in that set. Okay, let's move on to another example. Let's do number 50. So same directions, just more elements. 50. Oh, that looks so good. 55. 5. Well, I already wrote 55. Okay, so border, so types of dogs, right? A collie and a poodle. I'm trying to think what a border looks like. I gotta Google it later. And a poodle. I know collie is like Lassie, right? I think. Okay. Anyways, so list all the subsets of the given set. Okay. One of the subsets is always going to be the empty set. So the empty set is one of them. The next one, that's a comma. The next one is the full set itself. So we write border, collie, poodle. Okay, that's 2. Another set. Okay, maybe let's write this vertically, actually. You don't have to write it vertically. I think it's easier to, for me, I'm a vertical learner. So let me explain this vertically. Okay, something is wrong with my eraser. It's not working out. Okay, let's ignore that. So I have the empty set, that's 1. And I have, okay, the whole set. So border, collie, and poodle. And let me just move this up. Okay, and the next one maybe, so there's 1, 2, how about, well, I can just say border and collie, right? That set still lives in here, right? Well, the border and the collie are here. How about collie and the poodle? Or how about the border and let's see, and the poodle? So how many sets do we have so far? 1, 2, 3, 4, 5. And let's see, are we missing a set? Oh, we have the singletons. We can have just the border. We can have just the collie, right? These are the singletons, like when I was talking about Maria and Danny, right? The element, the set with one element. I can also have the poodle, so I have 1, 2, 3, 4, 5, 6, 7, and so I have 8. And I believe that is it. There are 8 subsets. Now notice that these are, okay, they're 8 subsets, but one of them is not distinct, right? It's not different. This was our original set, and notice, right, that's still a subset of itself, but it's the same one. So this is I mean, it's not a proper subset. So these are all proper subsets. So that is there's 8 subsets. The question doesn't ask it, but you are going to do it in 61 through 68. So we can say the distinct subsets are, in this case, would be 7 distinct subsets. Right, because every single one of them is different except that original one. So again, hopefully that makes sense. Oh, and one last thing, I promise. One last thing is I wanted to say this 8 actually, anytime you have a set with 3 elements, well, there's a formula for this. The subsets are always going to be, it's going to be 2, the power of 2, raised to the number of elements that there are. And let me actually maybe do this in, maybe make that blue. Just these are the elements, right? So 2 to the 3rd power, because there are 3 elements, border collie and poodle, and 2 cubed, right? If you multiply that out, that's just 2 times 2 times 2, which is 8. Okay, and that's how we got this 8. And again, we can see of course, again, the distinct subsets, right? It's always one less than the original subsets, right? It's all of these guys. These are the 7. Okay, I will stop here. I want to do more, but I'll just assign them on your ICA. Hopefully that helps, and have a good Wednesday.